like to welcome all those, both virtual and in Hyde County, to the Lake Mattamuskeet Watershed Restoration Plan public hearing, and not hearing, but a public meeting. The first item on the agenda, in addition to the welcome, will be a Lake Mattamuskeet Watershed Restoration Plan overview by Michael Flynn. Michael.
Thank you, Bill. And just want to let everybody know a couple of housekeeping items for those participating online. The mics of those attending virtually will be muted throughout the presentations. A recording of this will be made available for viewing on the project webpage later and show the use of the Q&A function. And you can use chat throughout the meeting if you have any technical issues. Please use the Q&A function to type in questions. If we have time in between presentations, we'll try to answer those. If not, there'll be 15 minutes at the end for open Q&A, and you can use the raise hand function. We'll call on you during that period so you can ask your question verbally if you'd like. After we provide this overview of the Watershed Restoration Plan, we'll have some updates from the technical working group. We'll review some of the agricultural cost share programs that are available to landowners, and then go into the details of the engineering active water management. So in 2017, there was a partnership formed between Hyde County, North Carolina Wildlife Resource Commission, U.S. Fish and Wildlife Service, and the North Carolina Coastal Federation to develop a watershed restoration plan. We identified 3 goals in there that included protecting the way of life of Hyde County, maintaining the existing land uses and industries within the watershed, actively manage the lake water level, minimize the flooding along the residential, business, and farm properties, allow for annual drawdowns as appropriate and in compliance with the refuge's management objectives defined in its comprehensive conservation plan to establish and maintain submerged aquatic vegetation within the lake and to establish and maintain a zone of emergent vegetation around the lake periphery. Additionally, a focus to restore the water quality and clarity within the lake by reducing nutrients, sediments, and phytoplankton blooms, promote the growth of submerged aquatic vegetation, and ultimately remove the lake from the state's 3D list of impaired waters. Working towards those goals, we identified in the plan development that active management of the lake level in addition to the tide gates would result in less frequent flooding of residential property, fewer septic system failures, adequate drainage of croplands, and to transfer some of the kind of water that is eutrophic at this current date and time to more clear and mesotrophic water, and reducing the nutrient levels that are within the water quality right now. As a result, you'd see fewer phytoplankton and cyanobacteria blooms. Working towards increasing the SAV abundance along the lake bed and emergent vegetation, reducing common carp populations, as you'll hear from the technical working group later today, increase of game fish and blue crab populations, and again, the ultimate removal of the listing on the state's 303D list by getting the chlorophyll A, pH, and turbidity parameters within federal and state guidelines. To attend to those desired actions, we had identified a few priorities that included creating a formal body that provides management authority for active water management within the watershed in close coordination with the refuge, which would be excluded as a formal body since the Fish and Wildlife Service cannot cede management authority. We perform a hydrologic study of the watershed, which has been completed to date, and design engineered plans for active water management within the lake watershed by evaluating where infrastructure improvements might be beneficial, additional outlets, and the use of potential sheet flow sites, which you'll hear more about tonight. As we've gone from development of the watershed restoration plan to implementation, seeking funding to implement those priority management actions has been the priority. Say, from 2019 to 2020, and funding was awarded from the Clean Water Management Trust Fund, the State's General Assembly, and the National Science Foundation. That funding was used to implement these priority management actions over the past 18 months. We had hired the geosyntech consultants in coastal protection engineering as the engineering firm to develop the hydrologic study and also develop some engineered designs that you'll see tonight. This has been done in cooperation with a robust stakeholder team that includes representatives from the county, U.S. Fish and Wildlife Service, Wildlife Resource Commission, and many residents of the community within the watershed we're working in. Additionally, a memorandum of understanding had been signed between Wildlife Resource Commission, Hyde County, and U.S. Fish and Wildlife Service to continue to see this effort through, even after the initial development of the watershed restoration plan. For those who would like to review the plan, you can visit the project website at nccoast.org/Lake Mattamuskeet. The plan, additional resources from past meetings are available for your review. And you can also subscribe for updates about future meetings and submit comments after viewing the presentation tonight. Next, we'll get a presentation from Wendy Stan, U.S. Fish and Wildlife Service.
Good evening, everyone. This is just a brief update from our technical working group, and my co-chair, Doug Howe from Wildlife Resource Commission, is also on a virtual call right now on this particular meeting. Next slide, please. So my updates are going to be very specific to the carp removal project. Based on communication and outreach, we have completed our compliance documentation, and that includes an environmental assessment with a 30-day public review that was completed this past summer. We also submitted an information bulletin about the carp removal project, and it was published by several local newspapers back on August 30th, 2021. And this was just basically a formal announcement of the $1 million large invasive species grant to remove invasive carp and how that will benefit the restoration of submerged aquatic vegetation, water quality, and water clarity benefits. In addition, the Coastal Review will be publishing another article based on the carp removal project, probably within their next cycle. Next slide, please. So one very positive outcome from our information bulletin was this congressional support from Congressman Dr. Murphy. We also provided a tour for him about a year and a half ago. We explained to him about the carp removal project then, and also the collaboration for the Lake Mattamuskeet Watershed Restoration area. Next slide, please. So as we continue with communication updates, we have installed some additional signs. You can see the brown sign on the left, and this is basically describing the carp gates or the carp barriers that we placed in the 4 tide gates at the 4 outfall canals. And again, these carp barriers are to block new incoming adult invasive common carp from the Pamlico Sound from entering the lake, but it still allows passage for native fish and blue crabs. And the other sign that you'll likely see around the lake is the water warning sign that we installed a couple years ago. This is a public advisory letting people know we have harmful algal blooms that do produce toxins in the lake. Next slide, please. So this is, the carp barriers are working at the tide gates, and this is some footage. This particular footage is from Wildlife Resource Commission fisheries biologist Ken Dockendorf. Can you play this for us, Michael? This is beauty to our eyes. These are carp that cannot get through that 2-inch spacings on those carp barriers. Next slide, please. Of course, I have one more footage I need to share. This is from Wildlife Resource Commission Officer Robert Wayne. Michael, could you play this for us? And this just shows all the carp in that bay at the tide gate. It cannot pass through those carp barriers. It's very, very exciting. Next slide, please. So some of the challenges that we're continuing to work on are, number one, the debris buildup in front of the carp barriers. And to help maintain the debris issues, we cut one of our gates, you can see right here on the left, in half, and that just makes it easier for us to lift that gate with the hoist system that a capstone project from East Carolina University designed for us. It's just easier and safer for us to be able to lift that up to try to flush debris. We've also installed this boom, and that's been really helpful directing the debris over towards that particular bay where we have that half-cut carp barrier. So I want to point out one thing. Every time we lift the carp barrier, there is an increased risk of adult carp entering the lake, and that's a concern we have. Next slide, please. So this year, I'm really excited. We have 2 new East Carolina University capstone student projects. They started in August. These are the senior engineering students. And for the first team, it's a Carp Deterrent team. And they are actually going to be working on a portable deterrent type device that we can place in that particular bay with that half-cut carp barrier to scatter the carp. Dr. Raymond Smith from ECU sent us the idea, and then Katie Potaka, one of our fisheries biologists with Wildlife Resource Commission, she's actually had experience with this. And so we're really excited with some of the ideas that this particular team is already coming up with. In addition, this team is going to design some deterrent devices that we can place around the culverts that go through Highway 94. And this basically will separate the east and the west basin and will be helpful when we do the maximum removal. Some of these deterrent devices will also be placed in some of our secondary canals to prevent adult carp from going up into these side canals in search of additional spawning habitat. So this deterrent team is going to really, their designs are going to be very important as we move forward. And just as important is our biosecurity barrier team. And this group of students is going to design that secondary barrier for the outfall canals. And this barrier, the primary and the secondary barrier has to fulfill what will happen if we have storm surge, we have water going over the tide gate, and that brings carp into the lake. So they're going to be looking at that, and they're also going to be looking at some type of secondary barrier placed in the canal in case that primary barrier is damaged. The reason why, again, we cannot use a deterrent type system there, such as a bubbler, electricity, or sound, those are some of the techniques that they are looking at, is because that will block all fish passage. And those outfall canals, we have to maintain native fish passage. Next slide, please. So some of our upcoming team actions, we're going to begin contacting local commercial fishermen for assistance with designing pound nets and other nets to use in the lake. We have some leads on some folks we're going to contact, and as Mr. Rich mentioned during the stakeholders call, he may have some additional names for us to contact. So we're going to be doing this relatively soon, probably within the next month or so. Second, we're considering conducting a carp market analysis to identify markets locally and nationally. And thirdly, we're going to retrofit additional carp barriers, basically cut in half to enhance debris removal at the other 3 outfall canals. And we worked with local welder, Mike Blizzard, for that first retrofit, and he just did a fantastic job for us. So we're hoping we can work with him again to get that done. Next slide, please. If there's any questions, I might have a minute or two to address any questions. I want to just sincerely thank all of our partners and collaborators, and I want to thank the members of the technical working group because the moral support, their expertise, and they're just amazing group of professionals to work with. And I think I can address a couple questions if there are any.
Thanks, Wendy. We haven't received any as of yet, but we'll continue to monitor and hold them until the end of the Q&A if they come in afterwards.
Thank you.
Thank you, Wendy. We'd like to introduce our next panelist.
The next panelist is Cruz Gibbs. He's going to give us an update on the agricultural cost share programs. Cruises with the Hyde County Water and Soil and Water Conservation District.
Good evening, everybody. As Mr. Bill stated, my name is Cruz Gibbs. I work for the Hyde County Soil and Water Conservation District. I am the NC Cost Share Technician, and I'm just going to give you all a brief overview of the practices that we are installing in Hyde County. For the 2021 to 2022 fiscal year, also referred to as the 2022 program year, the funding that we have received so far, and we normally get additional funding in the spring, but as of today, ag cost share is $34,535. Agricultural Water Resource Assistance Program is $7,500, and impaired and impacted is $7,348. The first practice, and as we go through these slides, the very first one is our district's top priority. So the first one we've got is precision nutrient management, and that entails a 3-year contract of GPS soil samples, 2.5 acres. And it's considered an incentive, so it pays 100% at $16.47 an acre. And the district has set a 250 acre cap. And with all these practices, the goals are pretty much going to be the same. It's all going to be water quality. And with water quality, we're looking at saving nitrogen, phosphorus, lime, and other nutrients. This is just a picture of a guy with a soil probe. I'm sure we've all seen somebody take a soil sample 100 days. And I'm sure we've all seen a soil test report, and that just basically tells you how much you need to put out on your field. The next one is water control structures. There's a 10-year operation and maintenance agreement, and it pays 75 or 90% based on your classification as a new farmer or a limited resource farmer. As far as pricing goes, it's dependent on the design and specs. And the goals for this is water management as far as direction, tidal, and flood. And again, you're trying to save nitrogen, phosphorus, and prevent salt water from intruding. This is a picture of a water control structure that was installed through one of our cost share programs. As you can see, this is the inlet side, and there are boards there to allow you to control the amount of water that is held on that farm. And then this is the outlet side, and there isn't currently a tide gate on this end, but there is potential to put a tide gate here, and we will cost share on tide gates too. The next practice is cover crop. You can either do an annual or a 3-year contract, and it's 75% at $38 an acre or 90% at $45 an acre. Again, that's just based on if you're a new or limited resource farmer. The district set a 150 acre cap. The goals with this practice is rain infiltration, soil health and organic matter by reducing wind and water erosion, and increasing nitrogen, phosphorus, and other nutrients for leaving the field. And then again, that relates back to water quality. This is a bare field that's been plowed, and if you don't implement a cover crop, I mean, it stays that way all year round. With a cover crop, after harvest, they've got 30 days to plant the cover that they're going to plant, and then after they kill it off, they've got 30 days to plant the crop that they're going to harvest. And then this is a field that's been implemented in our ag cost share program. Cover crop there is wheat. Next practice is land smoothing. It's got a 5-year operation maintenance agreement. Again, 75% at $205.88 an acre or 90% at $247.05 an acre. The district set a 40 acre cap on that, and the goals for that is water quality by reducing nutrient loss, reducing concentration flow of water, and improved infiltration. This is a box blade. This is normally used to pull dirt off the ditch banks. And then you can see here how he's going along the edge of a ditch and he's rolling it back off the ditch banks. And then they'll normally come around with something like this, which is, I call it a land leveler around here. And then they'll just go around in circles in the field, smoothing it out, putting a crown on it, basically in the shape of a turtleback or a bowl, if you want to think of it like that. The next one that we just added to our priority ranking is filter strips. It's got a 10-year operation and maintenance, 75% or 90%. And again, the price is all dependent on the design and specs that we get back. Got a 2-acre cap using only impaired and impacted funds set by the district. And impaired and impacted funds is basically the 303D list. So Lake Mattamuskeet's up there on it. And the reason we decided to do impaired and impacted is because that's going to have the greatest benefits there. The goals for that is water quality through reducing sediment deposits, preventing nitrogen, phosphorus, and other nutrients from leaving the field. This is a before pic, or not a before picture, but this is a picture of a field that doesn't have any filter strips implemented. And then as you can see in this picture, this is a field that's got filter strips at every ditch. There's a up close picture, and then this next slide is going to be just a picture of the single ditch. And this is a comparison of side by side. Field on the left doesn't have any, and the field on the right does. And that's the end of my presentation. If anybody's got any questions.
How wide are the filter strips?
It's all based on the design we get back. I haven't done any filter strip design, so it'd be based off the NRCS.
And then you said the cost share payment was 75 to 80. What is that cost sharing?
The 75 to 90%, that's based off of 75% is your average person. 90% is based off if you're considered a new farmer, which means you have less than 10 years farming experience, or you're a limited resource farmer. And there are a couple of different criteria for that.
I guess my question, I should have worded it more clearly. What is that cost sharing for? What are you sharing the cost of? Is it a rental rate?
Implementing the practice. So whatever, so your vegetation that's involved, any grading, anything like that.
So installation costs for the practice?
Yeah.
You know, they would have food drains through that filter strip.
I do not know. I can check.
I mean, it looked like on the picture there were drains going across the field. I don't know. They went all the way through the filter strip or kind of.
Be helpful to know.
Yeah, I can definitely double check and get back to y'all on that.
Thank you, Cruz. The good presentation and certainly in alignment with what our goals are as Michael presented in his original presentation. So that was great. Good information. Next up on the agenda is an engineering active water management update from Geosyntec and our CPE consultants.
All right, thanks, Mr. Rich. So today we're going to be reviewing the study goals and objectives associated with this active water management project, and then also review the selected alternative that has been selected with coordination with the stakeholder group in the Hyde County Board of Commissioners to progress to a preliminary engineering design. So we'll go over that was selected. And then we'll also touch on the current status of that engineering design, including looking at some of the components of the plans and future environmental impact analysis and the components of the active water management plan that are all going to be delivered as part of the scope. We'll also discuss some of the considerations for additional bathymetric surveys at the existing outlet canals and our next steps and schedule for the remainder of the project. So the study objectives are detailed here, where the first component was developing a watershed scale H&H model and calibrating that to the water level that was observed for Hurricanes Matthew and Joaquin, and then using that model to evaluate how the lake responds to various design storm scenarios, both in existing conditions, as well as with future sea level rise projections. So that's been presented previously at these public meetings. And then the next step was looking at various engineered options that could be used to actively manage lake water levels. We specifically used a screening criteria for the 10-year design storm and looked at various options, including using sheet flow sites, looking at standalone pumping operations, looking at dredging or removing sediment from the existing outlet canals to their design depth, as well as the selected alternative, which was looking at gravity drain canals that would drain north towards existing drainage districts. We looked at this 10-year design storm screening, and based on that, selected 2 alternatives that were progressed to evaluate for the entire suite of the design storms. And so that's been done, I think, since the last time there was, since the April public meeting. And then based on that, we selected, again, with stakeholder input and Hyde County Board of Commissioner input, one preferred alternative to develop permit level plans that could be used to go out and get additional funding for construction of this project, as well as begin the conversation with the permitting conversation. So this was a selected alternative, which was looking at 3 gravity drain canals that would discharge to the existing drainage districts at Fairfield District number 7 and Mattamuskeet Association. And so I do apologize, there's a typo that I have failed to correct. And we're looking at Jarvis Canal, Burvis Canal, and then Swindells Canal, which is adjacent to the Osprey Nest campground. And so the idea here is that there would be an adjustable water control structure like a weir gate that can be raised and lowered to control the flow of water between the lake watershed and the lake boundary to these drainage districts that typically have a lower elevation, operating elevation within their drainage network. And so we can use the gravity drained head of the lake to be able to draw down the lake levels, and then as a part of that, and to manage the additional volume of water that is coming from the lake into these drainage districts, there would be upgraded pump capacity that would handle that additional volume. And so it would be a cooperative effort between the drainage districts and what could become this service district that would help fund this operation. So based on that concept design, we have progressed now to this preliminary engineering design that consists of various civil design, process design, and mechanical design. And then we're also looking at, we're also developing a preliminary ecological impact analysis and a preliminary water management plan that would provide some operational considerations for making this concept work for both the lake watershed and the drainage districts. And so we'll go through some of the concepts here on that plan. We have developed a grading plan and location of water control structures and culverts as needed. We've also specified some preliminary channel cross sections, the dimensions of the water control structures and how those might operate. We've preliminary selected pump station sightings for each of the 3 canal improvements, and then also done a process and instrumentation design that would be used for a more full mechanical and electrical design, as well as some options for installation and typical section view of the pump. So this is the overall site plan. The first, we'll kind of go from left to right, but Swindells Canal here, I don't know if you can see my, okay. Whoop. new computer. So for Swindells Canal, it would be approximately 800 linear feet of improvements to widen that canal and make sure that it can convey the design flow rate. And then there would be a water control structure at along Piney Woods Road. That again, that would be an adjustable weir structure that could be raised and lowered based on specific management needs. Jarvis Canal, I'm sorry, going left to right, Burris Canal would have approximately 3,500 linear feet of canal improvements with a water control structure at North Lake Road. And then Jarvis Canal would have about 13,000 linear feet. And that would, the water control structure at North Lake Road as well. And so you can also see the pump stations where they're approximately proposed here. We'll go into a little bit more detail on that, but each of those pump stations would have a similar design with 48-inch pumps, and that could be operated, you know, all at one time or two at a time, depending on the needs of the pumping capacity that was needed. And the water control structures, again, the concept would be adjustable weir gates that the width would be based on the width of the canal and what was appropriate for each canal. And so here you can see some of the preliminary grading plan. There would be the bottom width of the canals would vary between 30 to 50 feet based on the location, and would be graded to have a slope that would drain away from the lake. And then as needed, there would be potential for upgrades of the culverts to convey the additional flow that would be coming from the lake. I do believe that Burris Canal, where I've shown that crossing at Piney Woods Road, there's a bridge there, so that may not be needed, the box culvert upgrade, but we'd look at that for Jarvis Canal as well. As for the water control structures, we are looking at an adjustable weir gate. So the conveyance capacity of the receiving canal are generally in excess of what would be able to be pumped by the additional pumping infrastructure proposed. That could be up to 180,000 gallons per minute if all three pumps are operating at one time. And so some of the operating considerations of how these weir structures would work is that you would need to set the weir elevations such that the flow that is being discharged to the downstream drainage districts would not exceed that pump capacity. So we've kind of put some preliminary bounds as a part of the active water management plan on what the maximum head could be to make sure that, you know, there's not a flow rate in excess of that volume. And so you can see that here for each canal, the canal or the weir width again varies based on the width of the canal as well as what makes sense for the canal. And so we've looked at a couple starting water levels where, and to explain this a little bit further, the weir gates would generally be fully closed such that there is not flow between the watershed boundary and the drainage districts until a drainage event occurred, which could be because there's a storm event coming and we want to lower the lake water level, or you know, the lake water levels not being able to be drained from the existing outlet canals because the sound level is high and that's becoming a problem. So then there would be a time where then the weir gates would be lowered such that flow could occur across that boundary. And so if we're starting at about a 2.5 foot gauge height, you can see that basically the weirs could be lowered all the way down to 0 foot gauge, and we would not have an issue exceeding the capacity of the downstream pumps. However, if we start, because the maximum weir head is equivalent to that 2.5 foot head. If we're starting at a higher water level, which would be the case if there was a very large storm event, approximately 50-year storm event peak was modeled to be about 3.5 foot gauge. Depending on the canal location, you would not lower it all the way immediately, out of concern of, again, exceeding that additional pump capacity. And so that just provides an example of some of the operational considerations that we'll be providing in the active water management plan. And also an understanding of how long, if these if these weir gates were lowered, how long it would take to drain the lake, as long as there's receiving capacity downstream. So for that, to lower it from 3.5 foot gauge to half foot lower, around 3 feet, it would take about 12 days to draw that down. So that provides an idea of how this would work. So we all have looked at some preliminary siting for pump stations. What has been proposed right now can be either powered by diesel generators or 3-phase power with power line extensions. And each of these locations could discharge water in the surrounding land for sheet flow application. So for the Swindells Canal Pump Station, which is here, it would be discharged to mill ditch towards the intercoastal waterway, or sheet flow to adjacent properties. For the Burris Canal Pump Station, there is the potential to discharge to North Carolina lands at the Gull Rock Game Land Carter Track. And then Jarvis Canal, there's a WRP land here that could accept some of this flow as well. So each of these has their challenges with implementing them from both a permitting perspective and an operational perspective. But there are options there, and to be able to use these pump station locations. Just to get an idea of how this pump station operations would work, we have the process and instrumentation design here. So there would be alarms that would be in level transmitters that would basically be able to tell the pump when to turn on and off. We're looking at 48-inch pumps right now, again, likely maximum capacity of around 60,000 gallons per minute, although that'll be dependent specifically on the final total dynamic head and other operating conditions. There will be controls on the pump itself to allow you to manually turn them on and off as needed, but they can also be automated. And then there will be additional controls downstream at the discharge to make sure that there's no backflow into the structure. So that kind of wraps up the status of the design currently. We do have a little bit more detail in the plans themselves, and if anyone's interested, I think they're available, and we have a couple copies printed out here as well for those who are in the audience. So we're also working on providing an ecological impact analysis, which would be a preliminary analysis to look at ecological impacts of the project. And so there's various components of that. We'll of course discuss the need for the project and how the alternative was selected based on the screening rationale during the development of the model. We'll discuss potential permits that are needed, but most importantly, the changes that might occur to the environmental features. And so this will be based on sheet flow application and moving water to different places than they've been in the past 10, 15, 20 years. And so the result of that will be an opinion of what these potential adverse impacts could be, as well as what needs more research. And so we've done our initial data review at this point, and we're in that evaluation of what the ecological impacts would be. And that's expected to be completed within a couple weeks. For the active water management plan, again, there will include a narrative of the conceptual design, which will discuss the components of the design that we briefly went over, as well as a description of construction methods, and then providing an opinion of probable cost based on AACE standards classified capital construction costs, as well as a potential annual operational budget, and what that might, how much volume of water that operational budget might be able to manage. So looking at that here, we've based, as a part of the H&H report that was prepared back in June, we developed some preliminary cost estimates, and we've updated those a bit based on the more detailed design. And so for implementation of all three projects, we're looking at about $6 to $11 million. I know that's a wide range, but there's still a lot of design details that need to be able to narrow down that cost a little bit more. And then looking at annual operational costs, we kind of base the budget off of various contributions of a per acre fee that was assessed on the watershed, and estimated how many hours of pumping at various flow rates you might be able to achieve based on that operating budget. And so to give a little bit more detail here, I'll go through each of these columns and explain what they mean. But the potential annual operating budget is based on $1 per acre charge that right now consists of the lake watershed. That is not within the refuge. So there's about an 18,000 acres. And so that is based on $25 per acre. You have about $475,000 budget, up to $35 per acre, about $675,000 budget based on that 18,000 acres that could potentially contribute to this. And so we looked at there are some fixed costs associated with operation and maintenance of the pumps, and this is also based on the use of a diesel generator and diesel fuel. And so there are fixed operational costs, O&M costs for that as well. But we were able to estimate based on, an average number of pumps operating and that average pump capacity across all three pump stations, how many hours might be achieved, and then also how that translates to annual drawdown volume. And again, so you'll see a difference in that because of some of those fixed costs and then the additional fuel consumption costs. And so as an example, the annual drawdown volume of 120,000 acre feet that could be achieved with that $675,000. So that's equivalent to about 40% or so of the storm volume that's generated on an annual basis. And so I think what we consider this active water management as another option, a tool in the toolbox that can be utilized to draw down lake water levels when they're high. In addition to what we're already seeing, water loss from evaporation or drainage capacity at the existing outlet canals, it provides another option to draw down the lake when there are high water levels that is stressing the surrounding community. So It is important to note that, you know, the watershed does include the refuge as well. And we're still exploring options to see how they may be able to contribute to help reduce some of those costs. But again, this is a range. It'll be based on, well, it'll be based on a couple things, but it'll be based on how the pumps are actually managed and operated. And really what will likely end up happening is that these pump stations are going to be located in the drainage districts, and volume that is managed will be charged on a per volume basis. So we'll be measuring at the water control structures, the volume of flow that is being managed by the drainage districts, and then they would charge on a per unit basis or per volume basis. And so what that number ends up being will be, I guess, a negotiation perhaps between the service district and the drainage districts to evaluate that, what that would be. So these are some estimates here to kind of provide a framework on what a drawdown volume might be able to be achieved. Oh, unfortunately, my animation didn't make it to this slide, but one other consideration that we've heard from stakeholders and are continuing to evaluate and look into is collecting additional topographic and bathymetric surveys to improve quantities of removal that would be needed to restore the outlet canals to their design depth, or original design dimensions. And so we have prepared a proposal to do that additional work to help, again, improve quantities and also update the model to be able to reflect better or more actual conditions compared to the LiDAR information that's in there right now. And so we know that this is something that stakeholder group in the public wants to continue looking at. It is something that the funding is based on state budget funding that's not currently not approved yet. So this is something we'd be looking at doing once that state budget is approved, and probably more in the winter time frame when there's less vegetation to help improve the collection of the data. So our next steps for the project are to finalize the plans based on feedback from stakeholder groups, and also finalize the environmental impact analysis and design narrative. As I said, we've looked at potentially collecting additional bathymetric data, and we'll like to move forward with that pending funding. And then the key component will be the finalization of the service district boundary, which could potentially include that additional bathymetric data. And one thing we've discussed is rerunning the model with the latest bathymetric data, but also the latest design, since we've had some updates from what was originally modeled in that 10-year screening step. And that could be used to better quantify the benefit that would be observed for landowners, both close to the lake boundary as well as that are within the watershed further away, so that there's a basis for developing the service district boundary, and potentially also looking at a tiered fee structure for those that benefit from this project specifically. But also I think the service district boundary would have multiple purposes, not necessarily just funding this one project, but also general management of water within the lake. So that's a consideration also. For a schedule update, we have had some schedule delays from our original proposal, which was about 13 months. We added in some additional alternatives analyses, some cost analyses. We had some delays with approval and decision-making. And so we started the project in June, and we delivered the primary first part of the scope, the H&H report, wetland siting conceptual costs, in June of 2021. And then we received approval at the Howard County Board of Commissioners meeting to move forward with the preliminary engineering design of the gravity drain canals concept. And so this meeting here is the today, and we submitted the drafted plans September 14th. We're looking at submitting the draft of the ecological impact analysis in early to mid-October. And then that narrative final permit level plans, and then service district boundary in late October. So, and that is, you know, pending the additional topographic and bathymetric collection of data as well. But certainly we want, you know, to continue to get feedback from the community and make sure what is being proposed, folks understand that, and that we're getting feedback. So with that, I will take any questions. And I don't know how to check to see if any came in. Maybe chat or Q&A. I'm not seeing any right now.
Yeah. Nothing from the audience online. Anybody here tonight?
I've got a question and then possibly a comment. Alyssa, back to your operating cost analysis. Did I understand that right to say that the projections that you had there per acre currently were based upon 18,000 acres?
They were.
Okay, and so the reason for that was because it's the general understanding right now that the refuge can't participate in the funding of that operational cost.
Right.
Okay, so I think that you're building this particular water management project or active water management project based upon servicing the entire service district. So without being harsh with my words, I think it's a bit disingenuous to only spread that operating cost over 18,000 acres. And I don't want to get into whether the refuge can pay or not. My only point is that acreage has to pay, and we have to find a way that it can be a contributor to the total of the operating cost. And I know we're still preliminary, but as far as things that we publish and we put out to the public to see and to study and to comment, we can't put a number that shows from $25 to $35 per acre and suggest that that's going to be paid by the private side of the service district. I don't think that's a good idea. And I know we've still got a long ways to go to get all this figured out, but I think we better start now as far as being realistic about, you know, operating costs so that, you know, at least we can remain constructively focused moving forward.
Yeah, that's a good comment and feedback, and something that was discussed during the stakeholder meeting earlier as well. You know, if we were going to spread that cost out across the entire watershed, that would drop from $7 to $10 per acre, which I think would be certainly there has to be economic feasibility in place for all people that will benefit from the project. So I think one of our next meetings will really focus on that discussion a little bit more and how that service district boundary would operate, but also how it would be funded. And so that's probably the biggest barrier to making the project happen at this
Yeah.
point.
What was presented earlier today and at the meeting tonight was the math, and then it was determined that wasn't palatable. We gotta figure out what will be.
Can I follow up on some of Wilson's comments? And I agree with Wilson to a good extent. I'm in the position of having family land, farmland in the Fairfield Drainage District and in the 18,000 acres. And I know which of that land is going to benefit from the project, and that's the land in the Fairfield Drainage District. I think it would be untoward of me to think that the land I have in Fairfield would not pay for improvements that would benefit it almost immediately. The land that I have on the south side of the lake is going to be like some of the last drops to move through that. And I manage on my own already. I can, because we have a pump and I've got a great farmer who pays attention to my wallet, I can, my pumping costs, just for your information, are maybe $8 an acre, $10 maybe in this past year, a real wet year. And that's, you know, the water that's right at the pump, so it's coming off my land. It makes a difference for my crop. The pumps that are going to be located over there have value. They have the most value to the land that they're near. That's in the Mattamuskeet Drainage District, in the Fairfield Drainage Districts. And again, as somebody who owns land over there, not a huge amount, but it's still, you know, something that would benefit. I think we need to think about how the water moves, and water that goes to those pumps is the water that's, the first water through it is the water that's nearest it. If you've run many pumps, you know that you can kind of run out of your water fast, even though you might have a lot of water, because all of a sudden you've got a spot, a high spot. And the water that's on the lake that's near Swindle Canal and Jarvis Canal, those are fairly shoaly areas. And the wind tends to not blow the lake toward those, at least in times of year when we need to move water off. Now you might get south winds or southeast winds, but those don't generally happen. Maybe in June when we're kind of dry before hurricane weather. I think the size of the basins that would have to be excavated in the lake are going to be problematic no matter who pays for the project, if we're talking about moving lake water through these pumps. And I'm not sure that ecologically, with a biological background, that that's something I would support, knowing the value of the lake bottom, you know, the SAV and what we're talking about as far as disturbing and adding depth and potential turbidity. And I don't know if that lake bottom would ever settle down. I don't know what kind of soils you're going to get into when you start digging deep in there. I did have a couple of questions for you, and I know you put a ton of work into this program, so thank you. Could you clarify for me that the costs that you've shown up there don't include any like sheet flow rental costs?
Correct. Right now at this time. So I updated this based on previous annual operational costs that were for standalone pumping that did not include the rental costs. So those do not currently include that, and that's something we can update.
Okay, and then your potential annual operating budget numbers are not necessarily projected costs. Right?
Correct.
And we're not saying that this is going to cost $600,000 or $500,000. We're just saying you might be able to raise that amount if it were $30 an acre, right?
Right, you're right. And so that's where some of the operational costs were back calculated to fit into that budget. And so it, you know, if you have a $500,000 budget to work with, then you have to manage the pumps to be able to achieve that. And so that's, it was kind of a back calculation into that versus saying, you know, if we, and that's certainly something we can do if we want to handle all of the flow from the average annual rainfall, we can look to see how much that would cost, but it'll still be dependent on varying factors.
Mm-hmm. Okay, yeah. Great, thank you.
Didn't look like there was
Yeah,
one that
there's
had come in from online.
Was the thanks. Thank you. Any others from the audience or those participants online? If you do have any questions that come up, I'm available by email here. and happy to continue this conversation. We'll, as I think Wilson noted, we have a concept now. It's how do we actually make that work for all the parties that would be involved. And Ms. Davis brought up a good point that for the service district to work, there needs to be benefit to those. And so part of the one thing that we had discussed was that a potential tiered structure such that those that see maybe earlier benefit might pay, you know, a little bit higher fee. But if it's going to be incorporated, it does need buy-in from the community. So those concerns are noted.
Thank you. That was a great presentation and great input from those hearing it. Michael, you have any other questions? Have there been any other questions that need to be addressed?
Not so far. We did allocate some time on the agenda tonight for just general question and comments. Anybody else wanted to make any other statements before we conclude this evening? Again, you can visit the project webpage at nccoast.org/Lake Mattamuskeet. You submit comments through there if anything comes to mind later, or some of the project contacts are listed there if you have any other questions you want to follow up on.
Thank you, Michael, and thanks for everybody and their presentations tonight. I thought it was a very good meeting. Thanks for those who tuned in. And if there's not anything else, we'll close the meeting. Y'all have a great evening.
You as well. Thank you.
Well,